for the our Lunch and Learn WebEx for this afternoon, avoiding common pitfalls on NASA's journey to the cloud. My name is Jeff Grunwald, and I'm the data center practice manager at Force 3. I appreciate everybody from NASA joining us today. NASA has a very close place in my heart personally. It's one of the reasons that I kind of went into technology in the first place. I had an uncle who was at NASA for over 35 years, and he had an opportunity to help me with my love of technology over the years. And it was interesting. A few years ago, my wife and I were at the beach, and we were walking down the main street, and I saw a t-shirt shop, and I saw a shirt in the window. So we stopped, and I went in and got it, and I presented it, got home, and I gave it to my uncle, and he loved that t-shirt. And it said, "Why, yes, I am a rocket scientist," because he was a propulsion expert at one time at NASA. So, that's where I get my love of technology, and the cloud is just the latest in the line of another technologies that we're going to. If we think about the definition of cloud and the evolution of it, I had an opportunity a number of years ago to talk to a senior technical executive from a large IT company, and he was talking to me about this idea of cloud and what cloud was when it was really first coming out as the term cloud. And I said, so let me get this straight. We're talking about the ability to have compute space and expand what you need for your compute space and get what you need when you need it and have your storage and everything. And when you're done, you give it back. And he said, yeah, that's pretty much the way it works. And I said, that sounds like timeshare operation or TSO, which was the way mainframe computers worked at the dawn of the mainframe era. And that is the concept of sharing resources has been around for a long time. But now we have better tooling, et cetera. If you move forward, about 15 years ago was when we first started hearing about cloud. And at that point in time, cloud really was your bits running on someone else's server. Well, now we've gotten to the point, there's a current definition that I really like, and it comes from the book Building Evolutionary Architectures by Neil Ford, Rebecca Parsons, and Patrick Cow. And it says that cloud really is a variety of technologies that allow rapid provisioning of systems or services from a shared pool of resources. Systems, services, shared pools. That's really what cloud is. And if you look, today cloud has reached the level that dictates the way people live their lives. And federal agencies, that means embracing the advancement of technologies, which includes the current trends in cloud computing. If you listen to what Kevin Murphy has to say from NASA, here you can see we're talking about large amounts of data. I mean, 12.1 terabytes of data per day from nearly 100 sources. That's a lot of data from a lot of places. And making this data accessible to scientists and researchers, as well as how to store and maintain it effectively, is really an ongoing debate. If NASA is going to look to the cloud as part of its strategy, it's essential to consider some of the advantages and disadvantages that go with cloud computing. So some of the advantages include accessibility, accessing your data from anywhere at any time in the same manner. I had a relative who recently needed a new computer. Their computer was over 10 years old and it was starting to break down a little bit. So they got a new computer. My wife and I went over to help them get everything set up. And during this process, they had trouble with their email. They said, I'm not getting email. There's things my neighbors are getting, I'm not getting. And I had to explain to them that no, it had nothing to do with their new laptop because the application was a cloud application, which means that their mail is actually someplace else. All they're doing is accessing it. And I actually brought my laptop over to them to show them that they could log in the same way using a different computer and see the same thing. So accessibility is one of the main advantages, as well as flexibility. Easily purchasing cloud services, creating flexibility to decide when to implement and when to increase capacity. Cost effectiveness is a major reason that people go to the cloud. Cutting expenses of formerly used for things like additional software by moving to the cloud. And another cost saving as well as time saving is maintenance. Cloud services providers do the infrastructure maintenance for you. You don't need windows of downtime. You don't need to take things offline. Your data is available to you all the time because they're taking care of the maintenance and making sure that you are not affected. But there's always two sides to every coin. And the cloud services come with a certain set of drawbacks. And while the rise of cloud computing has been astonishing, really, some problems occur. So some of the disadvantages, it attain to inconsistency. Performance on shared infrastructure can be inconsistent based on location, speed, and other factors that are really outside your control. Our friend flexibility. The advantage of being able to add capacity whenever you need it has a flip side. If agencies are not careful about giving capacity back when it's no longer needed, costs can spiral out of control. This loss of visibility is something that many organizations struggle with after moving to the cloud. A good example is this: a couple of years ago, there was a federal agency that had moved some of their processing to the cloud. And they saw some initial savings, but as they moved on, after about 6 months, they noticed that their savings were gone and they were actually spending more to be in the cloud than they were when they were not, before they moved to the cloud. And this was due to the fact of the flexibility that we talked about, where people were taking new regions, new areas to do their computing, but they were forgetting to give it back when they were done. Cloud is not, cloud is always seen as the ability to run what you need and have as much as you need. The problem is the cloud providers don't tell you, yeah, but that's not what you're not paying for what you use, you're paying for what you provision. So if you provision and you don't use it, they are more than happy to continue to charge you. So that flexibility has a two-sided coin, and you have to think about that as you're moving to the cloud. Another disadvantage is around privacy and security. Now, even though safety is at a high level with every provider now, there are still concerns about data breaches. And we're going to talk a little bit more about this. But with that being said, don't be fooled that security is only the purview of your cloud provider. According to Gartner, recent Gartner cloud computing statistics, more than 90% of breaches are the user's fault and not the provider's. And we'll talk a little bit more about that. And the final disadvantage comes back to costs, data transfer costs. Monthly outbound data transfer is charged on a per gigabyte basis. The cost for data flow across the network can be surprisingly large. An occasional gigabyte here or there doesn't make a difference, but it can still be a big mistake to replicate a frequently updated database across the country every few seconds, sorry, just because of you have a DR requirement. The same is valid for storage and using the data. There's one public cloud provider that has a tier of storage designed for long-term backups that's priced very seductively at less than 1/10 of a cent per gigabyte. And that works out to something like $1 per terabyte per month. When you hear those numbers, it's easy to imagine, putting aside the backup tapes and the way you're doing backups today and the hassles, for the simplicity of this type of service. But if let's say you need access to the data, that will cost you 2 cents per gigabyte, meaning it's 20 times more expensive to look at the data than it is to store it for a month. This means that you need to look at how much you're going to use your data, how often you're going to transfer data, how much data you're doing as you do your analysis of moving into the cloud. There's also some myths. So let's take a look at them and push them out of the way early on. The first myth is the cloud is always cheaper. Well, as we just were talking about a little bit, that's not really true. The reality is that as part of any migration strategy, you need to consider the total cost of ownership. There's many reasons to move to cloud, including quickly deploying new applications and the capabilities, or elastically scaling based on demand. But for some workloads, you may not see an immediate drop in operational costs. You need to conduct an assessment of what to move and the order in which to move before you start moving to the cloud. How you migrate should also be considered. Second myth is that all of the data should move to the cloud and all the data processing should be there too. The reality is there's not enough pipe and bandwidth for all of your data to be in the cloud. Attempting to move large amounts of cloud data to the cloud, end user, or to the edge can strangle the network. With data-intensive workloads or analysis, that requires a significant amount of processing. A hybrid architecture or decentralized processing may be a more reasonable model. An analysis at the beginning can really help you determine what should be moved, what maybe shouldn't be moved, or maybe where a hybrid situation can take place. The third myth is moving to the cloud is the same as outsourcing. The reality is that outsourcing has been one of the most popular methods of cost control for agencies that want to simplify the problem of inadequate IT resources. In outsourcing, a third party will monitor and keep handling the agency data, serving as an extension of your team and sometimes even sitting with your team. This lessens your trouble when it comes to building in-house IT skills, which can be expensive and needs an effort to manage. On the other hand, cloud services agencies rent pre-packaged IT resources from providers and then process the data themselves in a self-service fashion using infrastructure and resources supplied by the provider. Users process their data while operating the provider's resources on a self-service basis. You may, and in fact government agencies do, have very specific at times things that they want to see in the cloud. But at the end of the day, it's still the resources of the cloud provider giving you back. That's why we say sometimes there's a hybrid where you own the resources, and we'll talk a little bit about that. While outsourcing and cloud both use outsiders as part of their IT operations, the SLAs, cost models, and agency responsibilities are very different between the two. And the last myth is the cloud is inherently insecure and it can't support federal government workloads or data. The reality is that the security is always a concern specifically for our federal government. And while this statement may have once been true, it's simply no longer the case. There's a proliferation of industry mandated security frameworks and government standards like FedRAMP and RMF, as well as tooling and monitoring and dedicated enclaves. These all allow agencies to align to a broad set of data sensitivity levels, including those managed by the DoD and intelligence communities. The critical aspect of security in the cloud is the ability of everyone involved, NASA, the cloud providers, and the integrators to accurately delineate where responsibility lies for securing the different layers of application and infrastructure architecture. This is what I was referring to earlier. Everybody needs to understand how to do their part in securing the whole environment. The cloud service providers are securing the equipment and access to the equipment. The integrators are working with the applications, and NASA and any other user has to have user access and other access points that they control for security. Everybody working together is the only way to have good security in the cloud. So with those, let's talk a little bit about migrating to the cloud. It is, the statistic says Over half of the leaders say that's one of the biggest problems and challenges in any cloud strategy. So with that in mind, one thing to consider when moving into the cloud is what to put in it. This is not a one-time decision either, but must be part of the evaluation process every time you consider moving data or applications to the cloud. This is one of the most consistent errors that agencies make. Not thinking about what they're moving, if it's meeting their goals, if it will meet the criteria they need, or if it should be or can be moved to the cloud. One of the most consistent errors. You must look at it every time, whenever you move any application or any data set. Always do the homework required to see if it will benefit. Don't just assume. Applications that require a large memory may not be good candidates to move to the cloud without modifications. If you're going to move them, is it worth the modifications? There are application dependencies that need to be considered, particularly if an application you want to move to the cloud is dependent on an application you'll be keeping on premise. You also need to consider availability. Moving into the public cloud can give you greater availability, while moving into a private cloud gives you more flexibility and control over the whole environment. Another consideration is, what are the external dependencies you need to consider for the applications? An example, what about application data that's dependent on classified data sources or dependent on another application where availability may be a concern? Reviewing the patterns of utilization as part of the evaluation process is also very important. Understanding how your applications, systems, and servers are utilized is an essential aspect of capacity planning. Understanding your SLAs must include uptime guarantees, compliance considerations, data protection processes, and the process for repatriation if possible, as well as provider penalties for failing to live up to terms. One thing not to forget is about addressing scalability. Even federal agencies change dramatically in size over time. Intervals, you need to include intervals for reviewing the contract so that if your organization changes, your cloud capacity can grow or shrink with it. Also, take a good look at your IT inventory, and this is something that people forget about doing. Look at your entire IT inventory as you start moving. A typical initial step to the cloud migration process has to be looking at that. That discovery process should entail application metering, which we're going to talk about, to determine the actual usage of deployed applications. It is not unusual to find that anywhere from 10 to 20% of an IT environment is no longer being used. Retiring these unused applications can have a positive impact, not just with the cost savings, but by no longer maintaining apps and also allowing IT resources to be devoted elsewhere. And also by minimizing the security concerns about those obsolete applications. It also tells you if you have applications that are legacy applications, applications that need to still be used on periodically, but they may not show you any savings and they may not be candidates for moving to the cloud. So doing a complete inventory to know what you have is very important. Another early area for consideration when moving to the cloud, whether it be your first application or your last, are the data management policies. This is especially critical for NASA, whose business really is data. These policies ensure that the agency is appropriately managing and retaining the data. These policies will remain vital as you migrate to the cloud. Some of the key areas that you really need to pay attention to are data creation, access, retention, archiving, and deletion. You need to make sure that when you move an application to the cloud, you'll still comply with agency and federal data management policies. And when considering those policies, it's an excellent time to consider the strategy that includes data tiering. Tiering is kind of twofold here. We're talking about tiering your data. What data needs to be on high speed environments? What do you need to access that can be a little bit slower? And do you have any archiving needs or backup needs? Different types of data storage for different types of data. We're also going to talk a little bit about moving automatically between those tiers. As I've already mentioned, data transfer and data recovery are two of the cost factors that agencies have found which have hampered movement to the cloud. To find a happy medium between both the cost, convenience, and accessibility, a data tiering strategy really needs to be considered. But with data sets and storage environments growing exponentially, there's no way that IT teams can implement that strategy manually. You can determine what it can be, but it's hard to implement manually. Automated workflows and processes are necessary in order to reap the benefits of data tiering, whose main value propositions are summarized in both CapEx and OpEx. CapEx, or capital expenditure savings, by extending the capacity of on-premise high-performance storage platforms. Instead of provisioning additional expensive storage array, offload less critical data to capacity tiers. And operational expenditure, or OpEx model spending, using scalable consumption-based cloud storage resources. Cloud service providers offer tiered object storage options whose pricing varies according to performance SLAs. How fast do you need your data? Many data tiering platforms implement storage optimization methodologies such as data compression and deduplication or thin provisioning that are considered when lowering data storage footprints and costs. These storage efficiency features can be particularly impactful when it comes to tiering backup or archive volumes. Excuse me, take a little water. Moving data automatically among tiers ensures that performance tiers are freed up to meet their SLAs for the data that needs the fastest read-write response. As a result, end users and applications can experience significantly better performance. With cloud tiering, there's no need to make any change in the application level, since the tiering occurs exclusively at the data level. Cloud tiering works invisibly in the background with no disruption of processes. A good example of this is there's a federal agency that offloads their cold data, and for their purposes, that's data that they haven't accessed in at least 45 days. This data is automatically sent to the cloud object stored until it's needed, in which case it's moved automatically back on-prem for the performance storage tier. Now, this strategy was undertaken after a very careful analysis that showed that the cold data was used so infrequently that the data storage rates did not erase any savings provided by moving the data off to the cloud. Again, you have to understand the data movement, the amount of time, and how much it costs for data movement when you're making these decisions. An example of this kind of capability is the NetApp Cloud Tiering Service, which lets organizations extend their data center storage capabilities to the cloud with very little effort. No change to the application level and no changes to existing workflows and processes. NetApp has actually found that cloud tiering can optimize and scale AFF storage capacity by up to 20 times. The service is available both as a pay-as-you-go consumption model as well as the upfront term-based bring your own license model. When thinking about data, continuing on down the data path, when building a cloud storage environment, advanced data management for cloud storage is also critical. Provisioning and management of storage are essential, but agencies need to keep in mind several considerations. The availability to provision all types of storage, NAS, SAN, etc. SMB, NFS, and iSCSI support. What are you doing with your backup and recovery? What are your DR requirements? and that includes your RPO and RTO objectives, as well as multi-cloud capabilities. An example of data management software that delivers this control, protection, and efficiency to data with the flexibility of the cloud is the NetApp Cloud Volumes ONTAP. ONTAP is a cloud-based data management service built on NetApp ONTAP storage software and offers universal storage platform that addresses the agency cloud data needs. Those are things to keep considering. An area that you need to consider where the government agencies have mature practices is monitoring, reporting, and analytics. These operational practices need to be maintained and augmented when moving to the cloud to avoid the waste that was identified by Stanford University researcher Dr. Jonathan Koomey. Dr. Koomey found that more than 80% of in-house data centers have more server capacity than necessary. Since most agencies don't do routine checks to see how much capacity they're using, they end up paying for extra power, cooling, licensing, maintenance, and server capacity that never gets used. This is in conjunction with what I was talking about earlier about doing an IT inventory. You use a lot, if you have applications that need to be retired, that means you can also retire some of that capacity, whether or not you move to the cloud. It also has to do with sizing of requirements and of environments that we'll talk a little bit about. Because when you're moving from in-house to cloud, the extra cost rolls over with it if you're not careful. Dr. Koomey estimated that users were paying an average of 36% more for cloud services than they needed. So if you use the Gartner estimates that the data storage cost in 2018 were approximately $173 billion, that equates to potential savings of almost $62 billion in IT costs just by optimizing workloads. Now, the only way to identify the areas for potential savings in a cloud environment is by monitoring and analyzing process and storage environments. Those tools can leverage AI and other analytic approaches. Agencies can make data-driven decisions on how to gain efficiencies. Data-driven is the key. Let's not guess about it. Let's monitor it, let's examine it, and let's use the data to help us make the decisions. The goal from that is to identify the I/O patterns, evaluate application performance, identify policy compliance, and support capacity management and infrastructure resilience by focusing on the analysis of data that are associated with IT infrastructure. And this can be done and should be done for both on-premise and cloud resources. Now, when I'm talking about IT resources, I'm talking about everything that you use to support your mission. This includes cloud and on-prem. Note that cloud also refers to multi-cloud because it's a fact of life. When going to cloud, you're generally not going to use just one type of cloud. You're going to have more than one cloud vendor. It's essential to do this management of IT resources holistically as well and consistently, which means choosing your tooling carefully so that it supports your entire environment. The types of resources and data to look at include inventory data. So you can answer questions about inventory resources like hosts, storage systems, switches, disks, tapes, virtual machines, and servers. Looking at performance data, which deals with performance for volumes, applications, internal volumes, switches, VMs, hosts, and application nodes themselves. Looking at your communications backbone, your port capacity to understand switch port connectivity, port status, and port speed over time. All this can be used to help with and build chargeback data models, which can answer questions about capacity and allocated capacity and storage resources. The ability to examine these chargeback and accountability information for storage, for hosts, for applications, and projects or other entities provide valuable insights. Now, while NASA may not use chargeback in a traditional manner, it can be very useful for the budgetary process. We make assumptions in this budgetary process. Now we can take the data to see if we need more resources or less resources and how we can move the resources around, because as we all know, budgets are tight, and the more data you can use about what's needed and where it's needed, the better off you can be in serving your mission. Now, at the end of the day, while these are referred to as monitoring tools, they serve multiple purposes. The traditional monitoring purpose to provide end-to-end visibility to the infrastructure, but they also aid in troubleshooting during processing by providing insight to determine root cause and reduce mean time to repair. We've all seen examples when there's a problem, a slowdown, some sort of processing issue where there's a giant phone call, or if we're all in the office, they have a big conference room and everybody comes in. The compute people are there, the network people are there, the storage people are there, the virtualization people are there, the operations people are there, and everybody's going through reams of data, either in paper or online, to try to determine what the problem is, what they're seeing, but they're seeing it in their own little view, and everybody starts pointing fingers. Well, we're seeing slowdowns because the network is slow, and the network's like, well, we're seeing network because the storage is taking up, and everybody starts pointing fingers. What these tools can help you with, besides the sizing, is actually, if you're running them as part of your processing as well, you can see where spikes are. You can compare it to typical processing and determine and help rule out or rule in where to look first. And it can significantly reduce the mean time to repair. Another thing that these tools do is allow for informed decisions when helping to resize and reclaim resources to optimize IT spend. And finally, they provide a level of detailed reporting to help justify the resource decisions and align your IT costs going forward. The reports can be used to provide valuable usage information that can help inform decisions about moving data and applications to the cloud and how they might perform in that environment. There's a use case about an agency a few years ago, and as they were moving to the cloud, they did not use what they knew about their applications. They knew that it was sized on site. They had a bunch of VMs to do their mission. There were 8 gigabytes in size, because at the maximum, that's what they needed. This is an agency that brings in data all the time, that's doing a lot of work with the data, that's doing some analytics, but on a very regular basis, they have to provide specific reporting. That processing takes place over about 2 days every month. So they had sized their environment for those 2 days. But the rest of the month, that environment, those VMs, and there were multiples of them, ran at less than 4 gigabytes of RAM to do what they were doing. So if you look at that, they had provisioned more than twice of what they needed on a normal basis. When they moved to the cloud, that's what they did. After a significant amount of time in the cloud, they started running monitoring tools and found this information out. They wasted a lot of money by over provisioning what they had. If they had used the tools and looked at their environment as they were making decisions, they could have significantly saved money from the get-go rather than waiting over time. That's why, as you're going to the monitor, as you're going to the cloud, don't forget about the things you do well. What is your processing? What are your procedures? What are your monitoring and reporting, and how can you improve them? But you do them from the beginning. If you do them from the beginning, you can see savings and get insights from the get-go rather than waiting over time. So an example of this, I wanted to give a quick example of the type of reporting I'm talking about. And this is a real-time reporting, but you can also do this for over time for historical. This specifically is a storage capacity report from the NetApp on-command insight. And you can see that it shows total capacity, used, provisioned, and available capacity. It breaks things out by storage vendor, by tier, by application cost, by project, and it shows some forecast information and costing trends. Reports like this can answer questions about capacity, file system utilization, internal capacity, port capacity, and virtual machines. And these can be used for insights for storage capacity resource planning, including storage and storage pools by showing capacity on the floor and in the cloud, as well as capacity usage in storage pools over time. So once you complete the analysis, you see a lot of these things, you're making decisions, you have an understanding of all the requirements for your cloud application and data, and you're ready to move, how do you go about it? Well, there's several methodologies. Lift and shift is one, re-architecting is one, and there are several more for migrating to the cloud, but one thing is clear. It's a process that does not happen overnight. It's also a process that shouldn't be rushed. I recommend including a bridge to cloud approach, no matter what methodology you use, where risk is reduced by first migrating to an on-prem private cloud. This approach provides you the ability to test and develop process in an environment where you still directly control all of the components. You don't know what you don't know, but if you control all of the components, it's easier to determine how things fit together. Bridge to Cloud also provides the ability to start monitoring from the beginning and determine the characteristics and the reports needed for new workloads. This reporting can be used to provide valuable information that can help inform decisions about moving data and applications to the cloud and how they might perform, which can help avoid surprises after final deployment. The story that I just told about the users that were using twice as much RAM as they needed, that whole problem could have been known and avoided if they had done their monitoring and seen what their characteristics were before they fully migrated to the cloud. So thinking about some tips and lessons learned as we start to wrap up here. There are multiple examples of successful and unsuccessful cloud migrations that can highlight some critical aspects of how agencies can get started in this journey. One of the biggest mistakes that agencies make in their cloud journey is project scope. It's important to start small with a digestible plan. And if you can't manage that, then split up your journey into small, reachable phases. You don't have to move the entire data center at one time. It's best to break everything down so you'll be able to handle some inevitable roadblocks. You also will want a master plan that touches on a number of key components, like start by identifying what your agency's need is. Is it a space consideration? Is it flexibility? Is it the ability to scale up and scale down? Is it a money concern? What is it that you are trying to achieve? Make sure that you consider security in every step as you're moving. Plan on monitoring the implementation. Don't just tell somebody to do it for you. You need to monitor. You need to check for the change management so you're getting what you need at the end, and you need to monitor support. You need to start. You don't need to start, but I recommend you start with less mission critical applications. Do something that will give you a level of success quickly so you can build momentum to do some of the more critical tasks. And make it a repeatable plan for moving to the cloud. how you're going to do it, what the benchmarks are going to be, what the criterias are for moving forward, how you're going to determine your monitoring, what your backup is going to be, what the plan to run in parallel is. When you move to the cloud, a lot of times it is very important to run in parallel, some in cloud, some in normal, so you can see if there are differences in running between the two and fix those before you do your final cutover. In the end, the tricky problem with the cloud computing is its best feature, its infinite ability to scale and handle any demand, is also a budgetary minefield. Is, how much is your user going to use on average? How much memory will they need? When we start these projects, it's really impossible to know. There's an old solution, we used to buy a fixed number of systems. We bought the servers, we bought them for the project, we made them, found over time that as demand spiked, we felt a little uncomfortable, but at least the budget cost didn't skyrocket. The servers whined a little bit from the load, the users groused about slow response time, but you didn't get a panic call from anybody looking at the budget. Well, now you can pencil together and create your best guesstimate. And you may be right, you may not. Nobody will know until you get started. Then the users show up. And anything can happen, as we've seen. No one notices when you're correct and the costs come in lower. But when the meter starts to spin faster, the accountants, auditors, and the oversight committees begin to pay attention. The biggest problem is that the NASA budget doesn't scale like the cloud. Are there any questions? I didn't hear any as we were going through. Are there any questions? Anything I can answer for anybody before we wrap this up? If not, I appreciate everybody joining us. Thank you very much for your time today, and hopefully we'll get to see everybody soon, in person. If you have any follow-ups, we will certainly be more than happy to answer them. Thank you very much.